with our tutorial today because last Wednesday we have already completed the lecture for chapter 3. So today, instead of continuing to lecture chapter 4, I will do tutorial first, so that at least because we just finished the chapter, it will be back. You are still fresh, so it's easier for us to go through the tutorial question. However, I apologize. I attached the questions a little bit late. I only attached it this afternoon. So if you want to have the questions are now in the VLE as well as in your sharing in your files folder of your VLE. Okay. As usual, the questions. The one that I attached to you is also attached with the answer, the final answer. So you may use it to refer as you are doing the question. Okay, so let me share my screen first. Okay, so just to recap, if you forget, basically chapter 3 is not that difficult, but chapter 3 you can see that there's a few things that is already a little bit confusing, maybe confusing to you, because we did a little bit on the rate law, we learned a little bit on the rate law, we learned a little bit about the Arrhenius equation, the reaction rate constant. We know already how to calculate the reaction rate constant. We learn what's the rate law, and then we learn stoichiometric table. So we learn how to do stoichiometric table for batch. We learn how to do stoichiometric table untuk flow. And then after that, we learn to elucidate, or we learn to determine the concentration. How are we going to find the concentration? Okay. So in the lecture, if you realize, it's all done separately. Okay. So in this tutorial, you will see how actually the questions are formed. Ataupun sebenarnya, what does actually chapter 3 will do, teach you, or what does questions that will come out from chapter 3. Okay, so today we have 7 questions. Okay, so we will try to see how many that we can solve for today. Right, so first question, so as usual, during tutorial, of course, I think I do not expect you to do it on the spot because the questions are a little bit long. What's more important, as I told previously in chapter 2, is really understanding the question. The key is really understanding information, and then how we translate the information into variables, and then how then we use the equation to solve the problem. Okay, so let us go to the first question. So the first question says, the reaction below obeys elementary rate law. Okay, so dalam chapter 3, we already learned a rate law. So if you forget, rate law, we have 2 types of rate law. Either is elementary rate law or non-elementary rate law. Meaning it's either elementary rate law or bukan elementary rate law. Okay. What's the difference? The difference is in the reaction order. Okay, so just remember, if it's elementary rate law, if and only if the questions or the literature or the information stated the reaction obeys elementary rate law, then the reaction order of each of the reactant is equal to the stoichiometric coefficient. Okay, maksudnya, for example, in this case, we have 2 reactant, right? C2H4 and we have O2. Okay, so since the stoichiometric coefficient for C2H4 is 1, meaning it is first order with respect to C2H4. And because the stoichiometric coefficient of oxygen gas is 3, hence the reaction is also third order with respect to oxygen. Or we can say overall is first order with respect to C2H4, third order with respect to O2, hence overall order, this is fourth order reaction. So maknanya order reaction tu kamu just tengok saja stoichiometric coefficient, you just take the number, that will be the reaction order. Okay, so done. That's the first part of the question, meaning from that first sentence, you basically can already come out with the rate law. Okay, so kita dah tahu reaction order dia. Okay, so next dia kata, given C2H4 outlet concentration 4.5 mole per dm³ and O2 concentration 1.8 mole dm³. So in this question, dia give us the concentration of C2H4, concentration of O2. But you remember, right? Concentration, we always have initial concentration or outlet concentration, or sometimes we call it final concentration. So what's the difference? The only difference is initial concentration is the concentration before the reaction takes place. Kepekatan sebelum tindak balas berlaku, we call initial concentration. Any concentration when the reaction takes place or after the reaction takes place, that's what we call as outlet concentration or final concentration pun boleh. So in this case, they give the outlet concentration. Okay, so dia bagi kita, okay, C2H4 ni, we put it as A, oxygen gas ni we put as B. So as I told you, sebab dalam penyiraan kita normally you refer it as A, B, C and D. Okay, tapi dalam soalan, of course you are given the real chemical equation ataupun the real chemical reaction. So to avoid confusion, you straight away write down which is A, which is B, which is C, which is D. So the easiest way, as I told you, you just follow the sequence in the chemical reaction. Okay, maksudnya C2H4 is your A, O2 is your B, CO2 is your C, H2O is your D. So ultimately, the reaction is actually 1A reacting with 3B to produce 2C and 2D. Therefore, yang outlet concentration C2H4 yang 4.5 ni, so this 4.5 is actually your CA. Okay, sebab C2H4 tu kita punya A, dia beri kita kepekatan A, C2H4. So CA is 4.5. So kenapa bukan CA0? Sebab CA0 tu initial concentration. Not is means initial or time zero. So kalau dia tak kata initial, means dia adalah kepekatan semasa tindak balas ataupun selepas tindak balas dah berlaku. So dia become CA sahaja, tak ada not. So sama, oxygen gas pun, oxygen gas is our B. Pun dia kata outlet concentration of B. So CB 1.8. So maksudnya selepas tindak balas tu berlaku, berapa kepekatan A yang tinggal 4.5, berapa kepekatan O2 yang tinggal 1.8. Okay, done. Right. So dia kata next one, dia kata reaction rate constant 0.5 dm power 9 per mole power 3 minute. Okay. So meaning reaction rate constant. So you have learned, right? Dalam kita punya rate law, we have K. Reaction rate constant you have learned, right? So in this question dia beri kita dah nilai K tu pemalar kadar tindak balas tu adalah 0.5. Okay, so done. Dia dah beri kita CA, CB, dia beri kita K 0.5, and don't forget this is the reaction obeys elementary rate law. So bila kamu tengok soalan tu kata obeys elementary rate law, you straight away can already elucidate the rate law. Okay, rate law dia akan menjadi, dia saya cakap pasal rate law, meaning kita nak cari minus RA. Okay, again, I always talk about rate law. Sebenarnya kita cari minus RA, kadar tindak balas A. Okay, so minus RA equals to, rate law dia kata mesti ada K, the reaction rate constant. Okay, so you must write K. Then as I told you, the reaction order of the reactant, sebab the elementary rate law, kita tengok sahaja chemical equation. So it's because the stoichiometric coefficient of A is 1. So CA power 1. Technically power 1. Tapi kamu tahu kalau anything yang power 1, dia masih nombor yang sama. Maksudnya 4 power 1 is still 4, 5 power 1 is still 5. Sebab tu CA power 1, we don't write power 1 pun tak apa. Sebab dia masih sama. Okay. But B, you must be careful because for B, stoichiometric coefficient dia adalah 3. That's why it become third order with respect to B. That's why you got CB power of 3. So power tu adalah reaction order dia. So reaction order dia tengok stoichiometric coefficient kalau dia follows elementary rate law. So sekarang kamu dah tahu rate law dia, apa dia nak cari? Okay, soalan kata, first question says, calculate the rate of disappearance of oxygen gas. Okay, so sekarang kamu dah kena faham soalan ni actually is something that you learn in chapter 1. Chapter 1. So, benar kamu belajar chapter 1, tapi sekarang ditanya dalam chapter 3. So, soalan ni kata ditanya, what is the rate of disappearance of oxygen gas? Okay, so if you forget, we refresh back. Kamu tahu rate of reaction, we have rate of disappearance dengan rate of formation. Okay, apa beza dia? Rate of disappearance minus R, Rate of formation positive R. Itu beza dia. R tu kalau positive means you are finding rate of formation. If you are finding rate of disappearance, dia jadi negative R. Okay, so dalam soalan ni, dia nak rate of disappearance of oxygen gas. So rate of disappearance negative R. And because oxygen is our B, so they become minus RB. Okay, so again, kenapa minus RB? Soalan tu nak minus RB. Kenapa? Sebab soalan nak rate of disappearance of oxygen gas. Our oxygen gas is our B. So dia nak minus RB. Okay, so kalau kamu ingat sebelum ni, saya dah pernah ajar kamu. Okay, if ever you want to find the rate of any other species, tak kisahlah rate of formation ke, rate of disappearance ke, asalkan dia spesies lain selain daripada A, ataupun you want to find the rate of disappearance of formation of any other compound besides A, you have to first find minus RE. Sebab rate law tu yang tadi saya kata pasal rate law minus RE ni, rate law ni mesti berdasarkan minus RE. So kita cari reaction order, kita cari K semua tu, dia adalah berdasarkan minus RE. Means, kalau saya nak cari yang spesies lain, saya cari dulu minus RE, then only I can get the rate for other species in the reaction. Okay, so if you wonder why, because the rate law ni, yang rate law punya hukum ni, the law says this is to find for minus RE. So kamu kena cari minus RE dulu, then baru kamu boleh cari rate for other species. Okay. So first what we do, kita cari dulu minus RE. So minus RE, you already know the rate law. Kita dah elucidate. We have already find out the rate law as minus RE equals to KCA, technically power 1, CB power 3. Because first order with respect to A, third order with respect to B. Okay, so you just substitute in the numbers. The K is already given. K is already given as 0.5. So you replace K 0.5. Then CA, concentration of A. So dalam soalan ni, you are very lucky, is given directly. Concentration of A adalah 4.5. You replace 4.5. Concentration of B is also given directly already as 1.8. So I replace 1.8. So don't forget yang 1.8 tu CB tu power 3. So the 1.8 tu you have to make sure is power 3. So when you solve this, you first get the minus RA as 13.12 mole per dm cube minute. Okay, so as I told you, one of the way for you to check your calculation is to check your final answer punya unit and dimension. Okay, maksudnya because in the first place, you want to find minus RA. So minus RA ni kalau kamu ingat, dia adalah kadar kehilangan A terhadap masa. How much A disappear with time. So berapa banyak A tu kita measure in terms of concentration. So berapa banyak concentration A berubah dengan masa. So dimension, final dimension minus RA kamu, sorry, the final dimension of your minus RA must be concentration per time. So kalau kamu kira minus RA kamu buat pembatalan unit, you don't get the dimension concentration per time, surely there's something wrong with your calculation. Okay, so let us check. In our case here, you can see the unit is mole per dm cube minute. Okay, so you know right, mole per dm cube tu concentration, dimension dia adalah concentration. So kamu kena tahu beza tau, unit dengan dimension. Mole per dm cube tu adalah unit. Tapi dimension untuk mole per dm cube adalah concentration. Okay, same like minute. Minute is a unit. The dimension of minute is time. So concentration per time betul lah, because I want to find minus RA. I know the dimension of my final answer must be concentration per time. So if I get correctly, most likely your answer is correct. Okay. However, you cannot just stop there sebab you just find minus RA. However, the question wants you to find minus RB. Okay, so kalau kamu ingat macam nak cari minus RB, dia kena cari berkaitan dia with minus RA, of which you have to multiply with the stoichiometric coefficient. Okay, we have done similar question in chapter 2 sebenarnya, tapi masa chapter 2 tu kamu tak payah kira. Okay, kamu just terus ambil je nilai dia. Dalam chapter 3 ni kamu dah kena start kira. Tapi kamu kena faham what is the correlation between minus RB kepada minus RE. Okay, so if you remember correctly, okay, You want to find minus RB. Okay. The number on the right hand side can be positive or negative. Okay, depending on the role of the species in the reaction. What do I mean by that? Okay, in this case, kamu nak cari the rate of disappearance of B. You want to find how much B disappear. Then you check in the chemical reaction, B does disappear because B is a reactant. So saya nak cari kadar kehilangan, then B memang reactant, B memang hilang. They agree to one another. The left say I want to find how much disappear. The right say memang betul B disappear. They agree, hence the number will be a positive number. So kamu ingat nombor dia boleh jadi negatif atau positif depending on the role of the species. Dalam kes ni kita dah cari kadar kehilangan, B memang disappear, they agree to one another, the number is a positive. Then don't forget you have to multiply with the stoichiometric coefficient, the ratio of stoichiometric coefficient of your oxygen to your C2H4 or your B over your A. So the stoichiometric coefficient of B was 3. The stoichiometric coefficient of A was 1. So you multiply 3 over 1, multiply with your minus RA. Minus RA yang tadi kita kira tu. You multiply, you get the rate of disappearance of B as 39.36. Ataupun kalau kamu confused pasal stoichiometric coefficient ni, kamu just ingat kadar tindak balas ni berkadaran dengan stoichiometric coefficient. Maksudnya, kamu tengok dalam this chemical equation, 1A react with 3B. So, kalau A hilang sebanyak 13.12, B akan hilang sebanyak 3 kali ganda dia. So, 3 times 13.12, that's why you get 39.36. Okay, itu sebenarnya berapa banyak B yang sebenarnya hilang semasa tindak balas. So, you already saw part A. Okay, so then I go to part B. Okay, so part ni tak susah sangat lah. Part B, they want to find for another species. They want us to find the rate of disappearance of carbon dioxide. Sekarang nak kita cari kadar kehilangan untuk satu lagi species, which is carbon dioxide. So whenever you do this question, you have to remember two things. Okay, left and right. Okay, first of all, you kena clarify part yang sebelah kiri dulu. Sebelah kiri ni dia nak cari apa? Okay, so rate of disappearance, negative R. Okay, dia cari negative R. Tapi dia cari untuk CO2. So you check in the question, CO2 is your compound C dalam kamu punya tindak balas. Okay, so maknanya dia nak kita cari minus RC. Apa maksud dia? Maksud dia nak cari berapa banyak pula C yang telah hilang semasa tindak balas. So now you know, left part is minus RC. Now you look at the right part, the number pula. Okay, nombor tu kamu kena ingat. Nombor tu boleh jadi positif, nombor tu boleh jadi negatif. Okay, so kamu just kena ingat, dalam kes ni, I want to find rate of disappearance. However, in the reaction, CO2 is produced. Okay, kita nak cari kadar kehilangan, tetapi CO2 tak hilang. CO2 is produced sebab CO2 adalah produk. So, they don't agree to one another. That's why the number akan ada sign negatif. So, nombor tu boleh jadi positif dan negatif bergantung kepada apa yang kamu nak cari dan apa peranan that species in the reaction. So, in this case, I want to find how much CO2 disappear. But in the reaction, CO2 doesn't disappear. CO2 is formed because CO2 is a product. They don't agree. That's why the number will have a negative. So, negative, then you don't forget, you must again multiply with the stoichiometric coefficient. C over A. Okay, sebab CO2 tu C kan. So C over A multiply again with minus RE. So minus RE tu takkan berubah. Minus RE will never change because you calculated as long as the concentration tak berubah, suhu tak berubah, nilai K tak berubah, minus RE takkan berubah. But your value negative RC, you kena kira lah berdasarkan that minus RA that we have obtained previously. So the C per A is 2 over 1. You can check for the chemical equation is 2 over 1. So 2 over 1 multiply with your minus RA, 13.12, you will get as negative 26.24. So usually this is not a difficult question, tapi positive negative sign tu you have to really remember when it become positive, when it become negative. Okay. So then last part for today, for this question is the rate of formation, of H2O. Okay, now they want to find rate of formation of water, H2O. Okay, so again, kalau rate of disappearance negative R, rate of formation positive R. Tu beza dia. Kadar kehilangan negative R, kadar pembentukan positive R. Then water. In our equation, water is your D. Dia A, B, C, D. So dia nak kita cari positive RD. Okay, nak kita cari positive RD. So again, sebelah kiri kamu dah tahu kamu nak cari positive RD. Now you look at your right hand side. So your right hand side, ingat dulu number tu boleh positif atau negatif. So dalam case ni, we want to find rate of formation of D. Okay, in the reaction, D does being formed. D is formed because D is a product. Water is formed in the reaction. So nak cari kadar pembentukan, and dalam tindak balas memang water tu terbentuk, memang D tu terbentuk. It agrees to one another. The number is a positive number. So either you want to write the positive, you don't want to write, so it's fine. Kalau positive kita understandable. Kamu tulis tak tulis, kita tahu dia adalah positif. Okay, so you can write, you don't write, it's also fine. Okay, then don't forget, multiply with your D per A, your stoichiometric coefficient ratio, multiply with minus RA. So again, minus RA tak berubah, minus RA masih sama, but you have to multiply with the stoichiometric coefficient. You check from the equation. For water, the stoichiometric coefficient is 2. The stoichiometric coefficient for C2H4 is 1. Okay, ataupun kata lain, for species D, nombor dia 2. For species A, the number is 1, the stoichiometric coefficient. So 2 per 1 multiply with 13.12, you get 26.24. So that's the rate of formation of your water, which is your product D. Okay, so done for question number 1. It's not that difficult, just that you have to remember a little bit of chapter 2 punya, they mix chapter 1, chapter 2 punya lesson as well as chapter 3 punya lesson. Okay, so as usual, I will give you about 1-2 minutes break. If you are doing it, means I give you 1-2 minutes to at least try to finish it up. Okay, then after that, I will come back in 1-2 minutes to continue the next question. Okay, so we are done for question number 1. So I think it will not be that much of a problem. So we will try to go to the next question. I think question yang lebih susah adalah question part yang stoichiometric table and so on. Okay, let me make it bigger. Okay, so next question. Okay, the question says, orthononitrochlorobenzene, ONCB, and aqueous ammonia react to form orthonitroaniline, ONA, with an activation energy of 2.5 kilojoule per mole and a pre-exponential factor of 0.5 liter per mole minute. Okay, so let us see. First question, soalan kedua, the first information, they give us the chemical reaction. So the chemical reaction is, okay, you have one ONCB reacting with 2 ammonia to produce 1 ONA and 1 NH4Cl. Ataupun we can also write it down, if you want to write in terms of alphabet, dia menjadi 1A reacting with 2B to produce 1C, 1D. Okay, so kamu tengok your stoichiometric coefficient dia. Okay, so 1A, 2B, 1C, 1D. Okay, so that's the reaction. Okay, so now that you already go to chapter 3, the stoichiometric coefficient is very important. Make sure you really check berapakah nombor di hadapan spesies tu dalam chemical equation dia. Okay, next dia kata activation energy. So if you remember, we learned activation energy is used to calculate K. So kalau kamu tengok ada activation energy, kamu tengok pre-exponential factor, it already tells you definitely have to use the Arrhenius equation, or to be more exact, it will be used to calculate your K, reaction rate constant. Hanya reaction rate constant kamu saja yang K tu will need you to know this information. EA, activation energy, and A, your pre-exponential factor. Okay, so need EA, activation energy, pre-exponential factor, your A in your Arrhenius equation. Okay, tak apa, kalau kamu tak familiar lagi, it's very fine because you pun just learn last Wednesday. Later we see how it's used in the question. Okay, next dia kata, the non-elementary liquid phase reaction is first order with respect to ONCB and first order with respect to ammonia. Okay, so kita dah belajar dalam first question, dia kata that is elementary reaction ataupun dia kata dia obeys elementary rate law. Hence, your reaction order, you just see the stoichiometric coefficient dalam chemical equation. However, in this question, dia kata non-elementary. So, kalau bila kamu tengok perkataan non-elementary, kamu dah tahu means reaction order dah tak ikut stoichiometric coefficient. Again, I mentioned, if it's stated non-elementary, what does it imply? It implies that reaction order dah tak ikut stoichiometric coefficient. So that's why the information yang order tu diberi dalam soalan. Sebab dia dah tak ikut persamaan kimia, kita dah takkan tahu dah. So the information must be provided to you. So information tu dia diberi sini, dia kata first order with respect to ONCB. ONCB kamu A kan? So maksudnya dia first order with respect to A. And first order with respect to ammonia. Ammonia is your B. So first order with respect to A, first order with respect to B. So kalau kamu tengok, betul lah kan, dia tak sama dengan persamaan kimia kan. Persamaan kimia kita first order dengan A, second order dengan B. Tapi sebab dia non-elementary, dia dah tak ikut. Sebab tu information tu diberi kepada kamu, dia kata first order A, first order B. Okay, so you have to remember that part. Okay, so let us go to the first question first. So that so far, that's the information given to us. Alright, so the first question is calculate the reaction rate constant at 50 Celsius. So last Wednesday, in chapter 3, we have learned about Arrhenius equation. Okay, apakah itu Arrhenius equation? Arrhenius equation is used to calculate K. Kan kita ingat tadi dalam soalan pertama kan dalam rate law kita kan ada nilai K kan. So nilai K tu macam soalan pertama is given to you directly. Kalau dah beri terus gunalah. Okay, but in this question, for question number 2, the value of K is not given directly. You have to calculate by yourself using Arrhenius equation. So if you remember, Arrhenius equation dia senang je. K equals to A is your exponential factor, your pre-exponential factor, exponent, okay, exponent power, minus a negative EA per RT. So don't forget dalam formula dia adalah A exponential power negative EA per RT. So agak kerap student forget the negative sign in the equation. Okay, so make sure you know ada negative sign dalam equation. Bila kamu kira, kamu kena kira yang negative sign itu dalam pengiraan kamu. Okay, so kamu repeat sajalah one by one. Sebab A pre-exponential factor, question already tell us pre-exponential factor 0.5. So ganti 0.5, no problem, senang saja. Okay, then part exponential. So EA. So EA dia adalah dia beri 2.5 kilojoule per mole. But kamu dah tahu. I told you before. Dia punya equation ada minus EA per RT. The R is your gas constant. So for Arrhenius equation, or basically for energy, melibatkan part pengiraan tenaga or energy, R dia kamu ada dua charge sahaja. Either 8.3144 joule per mole Kelvin or 1.987 calorie per mole Kelvin. Either way pun dia ada kalori atau dia joule. Okay, so kalau soalan beri kamu the EA in the form of kilojoule, just remember you must convert to joule. Okay, so biasanya memang nilai EA ni nilai yang sangat besar. Energy kan, how much energy you need, right? So it's always big. So it's impossible for them to write 25,000, 16,000. It's impossible, not impossible lah. It's usually represented in the form of kilojoule atau kilocalorie. Tapi dalam pengiraan kamu jangan lupa that kilojoule must be converted to joule. So cara nak convert darab 1000 sajalah. Macam kamu pernah belajar kan 1 kilometer is 1000 meter. Sama konsep. 2.5 kilojoule, 25,000 joule. Okay, so just multiply with 1000. So my EA now become 2.5 times 10 power 3 or 25,000 joule per mole. Divide by your R. So as I told you, ada dua sahaja. 8.3144 atau 1.987. Tengok ni unit energy kamu, unit apa. Kalau in this case is joule. So the R value is 8.3144 joule per mole Kelvin. Okay, so then multiply with temperature. Arrhenius equation kata kena multiply dengan temperature. So kamu kena ingat, dalam R value ni, unit temperature, my dimension unit is Kelvin. However, in my question, the temperature is given in Celsius. So you just convert the Celsius to Kelvin. So by adding 273.15, very straightforward, just plus 273.15, you already convert Celsius to Kelvin. Okay, so when you calculate this, okay, please make sure you do this later. I will give you a little bit of time. Make sure you try to press this sebab memang kalau tengok on paper macam senang pengiraan dia. Tapi a lot of times test atau exam memang student tak boleh I don't know whether you're not familiar with pressing the calculator or whatever it is, tapi please make sure you are familiarized with pressing the calculator to get this answer. Okay, so kadang-kadang kita tengok macam straightforward, guna calculator boleh kira, tapi kadang-kadang memang tak dapat juga, which I don't really understand. Maybe salah tekan ke, tak familiar dengan calculator ke, but because this is exponential, so make sure you know how to use the exponential function in your calculator, in your scientific calculator to calculate, and make sure you get your K as 0.1972. Okay, before I forget, let us talk about the unit of your K. So this case pun sometimes you get a little bit confused. Macam mana kita nak tahu unit untuk K? Okay, alright. Kalau kamu ingat, we have learned in CPP, pembatalan unit kan, untuk kita tahu unit akhir. Okay, kalau kamu perasan, formula dia kata K ni sama dengan A exponential minus EA per RT. So kalau kamu ingat, okay, kamu when we talk about unit, you will never hear unit exponential kan? Maksudnya kamu takkan dengar exponential liter, exponential kilogram, exponential joule, exponential Kelvin, exponential ATM. You will never hear unit dalam bentuk exponential because it will never happen. So apakah implication dia? Implication dia means nombor all the formula or the variables inside the bracket, yang bracket minus EA per RT ni, dia punya unit tu eventually, bukan unit dan dimension eventually will become dimensionless. Dia tak boleh ada unit sebab dia tak boleh ada exponential unit. So maksudnya dia kena ada semua variables dalam kurungan tu akan membatalkan their unit and their dimension with one another. Okay, what do I mean by that? Okay, kalau kamu perasan dalam bracket ni, above, atas dia, pengatas dia joule per mole. Pembawah dia joule per mole Kelvin, Kelvin. So kalau kamu perasan, kesemua unit akan terbatal by themselves. The joule and the mole above will be cancelled with the joule and the mole below. the Kelvin will be cancelled as well. Okay, sorry, saya kena tak Kelvin sini. So this is 273.15 plus Kelvin times Kelvin. So you see, joule cancel, mole cancel, Kelvin cancel. So the entire variables inside the bracket is basically unitless, dimensionless. Okay, dia mesti sebab eksponen tak boleh ada unit. Kamu tak boleh ada tinggal unit dalam bentuk exponential. Hence, maka yang tinggal sekarang adalah A sahaja, right? So kalau kamu perasan, the unit and dimension of your A will be the unit and dimension of your K. Okay, again, the unit and dimension of your A will be the same the unit and dimension of your K. So kalau A kita, the unit was given as liter per mole minute, kamu ikut saja untuk K kamu, dia punya unit akan sama. Nombor tak sama, unit sahaja yang akan sama. So that's how you elucidate the unit for your K value that you have calculated. Right, so done for question number A. So quite straightforward. Okay, question number B. Okay, question number B dia kata sekarang, determine the reaction rate at 150 Celsius with an ONCB outlet concentration 2.5, ammonia outlet concentration 1.8. Okay, so first of all, apa yang dia nak kita cari? Dia nak kita cari reaction rate. So bila kita nak cari reaction rate, maksudnya dia nak kita cari minus RE. Kamu kena ingat macam ni je. Dia nak cari reaction rate means dia nak kita cari minus RE. Okay, so in this question, they want us to find minus RA, tetapi minus RA dia ada few syarat. Okay, the first dia kata, dia mesti pada 150 Celsius. Kedua, they give us the concentration. So, ONCB ni adalah kita punya A kan, ONCB is our A, ammonia is our B. So, basically, they give us CA 2.5, CB 1.8. Dia beri kita information ni, kepekatan A, kepekatan B, outlet concentration means concentration after the reaction has taken place. CA 2.5, CB 1.8. Okay, so they want us to find minus RE. Okay, so again, dia nak kita cari reaction rate kan, reaction rate minus RE. Nak cari minus RE, kita mestilah elucidate dia punya rate law dulu. So maksudnya rate law tu sebenarnya nak mencari minus RE. Minus RE itu apa? Adalah reaction rate. Okay, so again, mungkin kamu kata, tapi reaction rate, kenapa minus RE itu reaction rate? Sebab as I told you, memang kalau kita cakap pasal minus reaction rate, kita akan kira based on A. How much A disappear with time. Sebab A is our main reactant or we call it also limiting reactant. So kita cari kadar tidak balas, kita akan cari kadar kehilangan E. That's why it become minus RE. Okay, so first, kamu nak kena elucidate dulu. Apakah rate law dia? Okay, so minus RA, saya betulkan. So minus RA equals to, first of all, mesti ada K. Okay, tapi kamu kena be very careful because in this question, I taught you before last week, K is very sensitive with temperature. Means K akan berubah dengan suhu. And bila kamu nak kira kadar tindak balas, you want to calculate the rate of reaction, it must be at the reaction temperature of which you are conducting the reaction. Means, kalau soalan ni reaction dia pada 150, the reaction temperature is 150, my rate law tu ataupun reaction rate tu ataupun minus RA tu must be at 150. So what does it mean? Means the value of my K tu must be at 150. Okay, sebab tindak balas saya berlaku pada suhu 150, kadar tindak balas saya pada suhu 150. So kalau tindak balas saya nak berlaku pada suhu 150 means my K must be at 150. So you must be very careful about this part. Yang K tu sangat sensitif dengan suhu. Kalau suhu berubah, kamu kena cari K pada suhu tindak balas. Okay, done on the K part. The next, the back. Okay, so if you remember, the question says this is non-elementary rate law kan? But this says reaction dia first order with respect to ONCB, first order with respect to ammonia. That's why you get K, Ca, Cb. Okay, kita dah tahu rate law dia. K, Ca, Cb. So kita nak cari minus Re. So we do one by one. So first of all, to find K. Okay, so you might say that, tapi dalam soalan pertama kan kita dah cari K. it is true. In the part A, we did find the K. However, the K was at 50 Celsius. So you cannot use this K anymore sebab K ni dah tak sama. Sebab suhu dah berubah. Kamu pun tengok dalam equation ni kan ada T. So kalau T tu berubah, mestilah nilai K dah berubah. So you have to find the new K. So kalau kamu perasan dalam soalan ni, dia tak suruh kamu cari new K kan? Tapi kamu kena tahu sendiri. Kalau suhu berubah, saya dah kena cari K pada suhu tindak balas saya. So you have to do back again the calculation to find K using the Arrhenius equation. The rest are the same except now my temperature become 150. So again lah temperature tu kamu kena convert kepada Kelvin. Yang part lain semua sama. EA masih sama, R masih sama, your A is still the same. Just that kenapa K akan berubah sebab T berubah. T change, K change. The rest, EA takkan berubah, A pun takkan berubah. Okay, I hope you really understand this part. Bila suhu berubah, yang hanya berubah adalah K. EA takkan berubah, A pun takkan berubah. Okay, so when you recalculated the K at the new temperature, you will get 0.2457 liter per mole minute. Okay, now there's another one more way untuk kamu nak check adakah pengiraan kamu betul atau tidak. Okay, so one way for you to check, okay, you do remember I taught you in chapter 3, right? The K value actually increases with temperature. Again, I repeat, nilai K sebenarnya akan meningkat dengan suhu. The higher temperature you increase, the higher the value of K will be. Okay, so contoh dalam case ni, sebelum ni dalam soalan A, part A, you calculated the K at 50 Celsius. So K at 50 Celsius, kamu dah kira 0.1972. So by right, theoretically dan sepatutnya, nilai K pada 150 ni yang kamu kira must be bigger than 0.1972. So katakan kamu kira nilai K yang pada suhu lebih tinggi, katakan pada K 150, if you get the value lesser than 0.1972, definitely kamu dah kira salah. Sebab peningkatan suhu lebih tinggi, K mesti naik. So kalau kamu kira K baru tu, kamu tengok, kenapa K baru lebih kecil? Walaupun saya naikkan suhu, you check back your calculation, there must be some error in your calculation. Okay, so that's one way lah. Taklah 100% foolproof. Okay, mungkin nombor tu meningkat, tapi kamu salah tekan pun possible. Tetapi that's one of the way for you to check. The number must increase when I increase temperature. Okay, so done on the K. Alright, so kita dah boleh kira lah minus RA dia, straightforward lah. K, we calculated 0.2457, K at 150. Then CA is given as 2.5, tak payah kira, dia dah bagi. CB is 1.8, dia dah bagi, tak payah kira. We don't need to calculate, we just replace into the equation. So now you get your minus RA as 1.1057 mole per liter minute. So again, you can check the unit and the dimension of your final answer as a way for you to verify betul atau tidak. So kalau your final answer, you get the dimension, concentration per time, most likely betul lah kamu kira. Tapi kalau kamu dapat unit kamu, dimension kamu pelik-pelik, you better check back, must be somewhere error in the calculation. Okay, so we are done for part B. We go to the last part of question 2. Calculate the rate of formation of ammonia using the information in part B. Okay, so sekarang dia kata, dia nak kita cari pula kadar pembentukan spesies lain, which is ammonia. Okay, so kalau kamu ingat, in the equation, ammonia is our B. Okay, dia nak kita cari untuk spesies B, ammonia. Then they want us to find rate of formation. So kalau rate of formation, positive R. Spesies ammonia, spesies B, dia nak kita cari positive RB. Kan saya dah kata tadi, kalau kita nak cari kadar kehilangan atau kadar pembentukan of any other species, asalkan kamu ada minus RA, kamu dah boleh cari. Okay, so kita dah ada minus RA. Dalam part B ni, kita dah cari minus RA dia. So kalau tak ada perubahan suhu, tak ada perubahan kepekatan, minus RA itu masih sama. So kamu boleh guna je daripada part B tu, you can use in part C sebab dia tak kata sebarang perubahan. But let's say, okay, katakan dalam part C dia kata dia suruh kamu kira kadar pembentukan amonia pada suhu yang berlainan. Let's say at another temperature, then you must remember, kamu dah tak boleh guna minus RA pada part B sebab minus RA pada part B adalah pada 150 Celsius. So kalau part C tu suhu berubah, maksudnya kamu kena cari balik minus RA. Kenapa kena cari balik minus RA? Because the value of K dah berubah. Okay, so kalau suhu berubah, K berubah, minus RA berubah. Okay, but in this question, part C dia tak kata sebarang perubahan. So you may use the minus RA of your part B. However, don't forget, the number, macam tadi soalan yang nombor 1, the number can be positive or negative. Kamu kena check balik. Kita nak cari rate of formation of B, ammonia. Kita nak cari kadar pembentukan amonia. However, in this example, ammonia is disappearing because ammonia is a reactant. Nak cari kadar pembentukan tetapi ammonia disappear sebab ammonia adalah reactant. Hence, the number will have a negative sign. So don't forget letak negative sign. So part ni yang kamu kena betul-betul ingat. Nombor tu boleh jadi positif, nombor tu boleh jadi negatif. Kamu kena betul-betul tengok nak cari kadar apa dan peranan spesies itu dalam tindak balas. Okay, so negative. And the next, don't forget multiply with stoichiometric coefficient. Pun kadang-kadang terlupa. Don't forget multiply with stoichiometric coefficient. Untuk ammonia, the stoichiometric coefficient is 2. For your A, your ONCB, the stoichiometric coefficient is 1. So become B per A jadi 2/1. Multiply with your minus RA, which you calculated previously in part B, you will get your positive RB as negative 2.2114 mole per liter minute. Okay, so done for question number 2. So again, probably not that difficult, tetapi be very careful on calculation. Be very careful on practicing how to press your calculator, so on and so forth, so that you are familiarized with yourself for to calculate. Okay, so I'll give you about 1 to 2 minute break again for you to do your calculation. If you're doing it, then I will come back in 1 to 2 minutes time. Okay, all right. So done for question number 2. So we will move to the question number 3. So far memang not that difficult yet. Okay, alright. So we go to question number 3. So question number 3 onwards, the question on stoichiometric coefficient. Okay, sorry, stoichiometric coefficient pula. It's a question on stoichiometric table. Okay, so kita dah pernah belajar pasal table tu kan. So now we try to see the questions related to the table. Okay, so nanti kamu kena faham apa yang I think now so you realize right, question dalam chapter 3 is actually something that yang kita macam refresh balik apa yang kita belajar dalam chapter 1, chapter 2, kita tanya dalam chapter 3. So later kamu don't forget, when you go to chapter 4 pun, you will see some of the questions are correlated from chapter 1, chapter 2, chapter 3. So that's why macam reaction ni dia susah bila kalau macam we are going to chapter 4 this Wednesday. So kalau kita tak familiar dengan soalan, kita tak familiar or we are not so familiar lah dengan chapter 1 to 3, it become a little bit difficulty in chapter 4. So Rabu ni, make sure you attend the lecture for this Wednesday because I'm going to go to chapter 4 and honestly chapter 4 is the toughest chapter sebab dia ada banyak equation yang kita kena derive. So understanding tu kena penting sebab memang you are not expected to memorize. Tetapi kalau kamu tak faham macam mana di-derive, then you will get confused because you have easily 30 to 40 equation yang kamu kena familiarize. Kamu kena tahu macam mana, apa perbezaan equation ni dan what kind of equation to be used at what kind of situation. Okay, so tak apalah, itu adalah hari Rabu punya story. Okay, now we go to question number 3. So question number 3 now says 5 mole per liter of A undergoes a liquid phase reaction in a 15-liter batch reactor. Okay, so kalau kamu perasan, the sentence is very short sentence, right? But in this sentence, there are actually 3 information dalam satu ayat yang kamu kena betul-betul tangkap dan faham. Okay, first information adalah 5 mole per liter of A undergoes reaction. Maksudnya adalah, first of all, 5 tu adalah apa? Mole per liter tu apa? So, mole per liter, kalau kamu tak boleh hafal unit, kamu convert je unit tu kepada dimension. So, mole lah. Liter kamu tahu volume. So, mole per volume, it is concentration. Okay, tapi concentration kamu kena berhati-hati. Concentration can be, tengok spesies apa? Spesies A ke, spesies B ke, spesies C. Sebab dalam reaction ni kita ada 3 spesies. Tapi dia kata A. So this is concentration of A. Tapi concentration of A pun ada boleh jadi CA atau CA0. What's the difference? CA0 is concentration before reaction takes place. CA concentration when the reaction takes place. So kalau dalam kes ni kata undergoes. Maksudnya dia belum lagi menjalani tindak balas. So this is the initial concentration. Maksudnya ni adalah CA0. So CA0 5 mole per liter. So part ni yang kamu kena be very careful because let's say kamu tersalah interpret information, katakan kamu ingat 5 mole per liter ni adalah FA0 ataupun kamu ingat 5 mole per liter ni adalah epsilon naught. So with that one wrong interpretation of the very first number, basically the whole thing, soalan tu semua kamu kena salah. Means satu benda yang kamu salah interpret, the whole question tu terus dah jadi 0 marks. Okay, so you be very careful. Make sure kamu interpret the number dengan melihat unit tu dahulu. Tengok unit, interpret dimension, then baru kamu boleh interpret dia correctly. Okay, first thing, that's the first information. Second information, dia kata liquid phase. So, kamu dah kena ingat kan chapter 3, there's a very big difference antara liquid phase dengan gas phase kan. Tapi itu adalah when we are talking about flow reactor. Kalau batch reactor tak apa, tapi kamu mesti kena bear in your thoughts that okay, ni liquid phase reaction, batch reactor. Okay, kalau dia flow, kamu dah kena fikir extra sikit sebab dia dah ada sedikit yang berlainan. Tapi kalau batch, not so bad. Both phases, the calculation will be the same. So, second information. Third information, 15 liter batch reactor. So, apa tu 15 liter? So, kamu tahu liter, dimension dia volume. So, this is the volume of the reactor. They give us the volume of the reactor as 15 liter. So, kamu pernah belajar for batch reactor, dia macam concentration juga kan. Kita ada initial concentration, kita ada final concentration. So volume pun technically, volume reactor technically ada initial volume V0 and outlet volume V. However, we learn in chemical engineering, kita dah belajar kan dalam konsep logically, volume reactor will not change during reaction because your reactor will not expand, your reactor will not shrink. So based on this understanding. That's why we will put V naught equals to V equals to 15 liter. Means volume asal reaktor saya dan volume akhir reaktor saya in the reaction is still 15 liter. So next, third information. So bayangkan katakan 15 liter ni kamu salah interpret, kamu ingatkan dia adalah volumetric flow rate ke, kamu ingat dia adalah concentration ke, kamu ingatkan dia number of moles ke. So again, the whole question pun jadi salah because if you interpret it wrongly. Okay, so again, please make sure you really interpret information correctly. Bukan saja for my course, bukan saja for you to pass the exam, but in the real application, in the real world juga, this is very important when you are getting information either verbally or on paper. Interpreting variables is very important. Kamu tak boleh interpret dia salah. Okay, right. So next. The reaction is second order with respect to A and zero order with respect to B. Okay, so dalam soalan ni, kalau kamu perasan, dia tak cakap, dia didn't mention elementary or non-elementary. However, they straight away give us the reaction order. So dia kata sekarang reaction dia second order with respect to A and zero order with respect to B. Means what? Kalau kamu perasan, order yang diberi itu dalam soalan tak sama dengan stoichiometric coefficient. Meaning, you can interpret directly. Basically, this reaction is non-elementary. So, sebab non-elementary lah diberi kamu the reaction order specific to the reactant. Okay, so kamu kena faham. Okay, the question sampai dia tak akan cakap non-elementary. Tapi kalau dia terus bagi tu reaction order tu, kamu ikut sahaja. Okay, kamu ikut saja apa yang diberi. So they say second order with respect to A, zero order with respect to B. Okay, so done that part. Okay, next dia kata inlet mixture contains 50 mole percent reactant A, 25 mole percent reactant B and the remainder inert. Okay, so dia kata asalnya sebelum tindak balas berlaku, before the reaction occurs, in my system, in my reactor, dalam batch reactor tu, I have actually 3 compound. Okay, 2 is my reactant, A and B, and I have the third one which is an inert, which I don't know what lah, tapi dia kata dia inert. So, these 3 compounds initially, dia ada dia punya percentage, right, in terms of mole. Okay, so in terms of mole percentage dia, we have 50% A, 50 mole percent A, 25 mole percent B, then naturally inert pun 25% lah because total must be 100%, right? So, A 50, B 25, inert 25 mole percent. Tapi kamu kena ingat, although you are given in terms of percentage, as I told you, sama macam conversion. You are given in percentage, you must convert into fraction. Maka, we write it as YA0. So, kalau kamu forget apa tu YA0, Y refers to mole fraction, A refers to compound A, not refers to initial. Kan dia kata sebabnya adalah inlet mixture kan. So, initial mole fraction of A, 0.5. Initial mole fraction of B, YB0, 0.25. Initial mole fraction of inert, YI0, also 0.25. How you get 0.25? Total percentage, 100% is 1. 1 minus 0.5 minus 0.25, you get 0.25. Okay, so done. You already know the fraction juga. Initially fraction dia pun dah tahu. Okay. So let us go to the question. The question says, develop a stoichiometric table for the reaction. All values should be a function of conversion only by numerically evaluating all symbols. Okay, so soalan dia macam panjang kan, tapi basically dia nak apa? Dia nak kita buat table. 1, 2. Dia kata dalam table ni, everything must be in numbers. Except for your x. Sebab dia kata function of conversion. Maknanya so everything else must be in numbers except your x. Dia is leave as it is. So x tu tinggal, yang lain semua dalam bentuk number. Okay, so how do we do the stoichiometric table? So as I always told you, before you start stoichiometric table, kamu dah kena faham konsep what do you need in order to start a table. So kalau batch reactor or batch system, selagi kamu tak ada Na0, you cannot start the table. Okay, so apa tu Na0? Initial number moles of A, Na0. So kalau kamu tak ada Na0, you cannot start the table. Kalau kamu start the table pun confirm table tu salah. Okay, so kalau initial number moles of A, mestilah dimension dia adalah mole ataupun unit dia pun mole. So kalau kamu perasan, again in this question, there are no numbers that have the unit mole ataupun dimension mole. Kamu perasan tak ada kan? Yang ada adalah hanya concentration mole per liter and volume liter. Okay, so tu, however, kamu kena ingatlah, there is a correlation antara Na0, Ca0 dan V0, where we know that Na0, the initial moles of A will be equals to initial concentration of A multiply with the initial volume. Okay, so again, kalau kamu tak pasti ataupun you are confused, dia bahagi ke, darab ke, as I told you, buat sahaja pembatalan unit. That is the easiest way. You don't need to memorize. You do the unit cancellation. So contoh dalam case ni, katakanlah we assume dia mesti multiply. We assume Ca0 must multiply with V0. So you try out. So you know Ca0 5 mole per liter. Okay, you know V0, the initial volume is 15 liter. Okay, so kalau kamu tengok, unit liter ni boleh terbatalkan, satu di atas, satu di bawah. We can cancel it. So we are left with mole. So most likely betul lah sebab kita nak cari initial moles of A, bilangan mole asal A. Kita dapat unit kita, jawapan akhir tu unit kita mole. So most likely betul lah. Tapi cuba kalau kamu kira, let's say you get your final unit tu liter per mole ataupun liter ataupun something is not mole, kamu dah tahu, definitely dah salah. Okay, so in this case, when I calculated, my Na0 is 75 mole. Once you dah dapat 75 mole, dah dapat Na0, then only you start doing your table. Selagi tak ada Na0, kamu tak boleh buat table sebab confirm table tu akan salah. Okay, now that you have obtained the value, now you start doing the table. Okay, so kamu kena ingat pula, dalam table tu, kadang-kadang student lupa, okay, what are the species that you have in your table? Okay, so okay, row pertama mestilah row yang spesies, simbol, initial, change, remaining. Okay, so since our mole, the unit is in mole, sebab mole, sebab dimension mole, unit dia boleh jadi mole, boleh jadi kilomole, boleh jadi pound mole. Itu adalah unit, dimension dia mole. Dalam kes ni, dimension mole, unit pun mole. Means SI unit lah, kita guna mole. Kamu ingat kalau American Engineering Unit, dia guna pound mole. Kalau SI, mole. Sometimes kilomole pun boleh, but in this question, mole. Okay, so nak senangkan daripada kita nak tulis every box tu mole, you just label directly initial, change, remaining, you put the mole inside, the unit inside bracket, so dah tak payah tulis untuk setiap kotak first. Okay, so done. Then you must remember all the species in the system. Okay, mesti ada baris dia sendiri. So in this case, I have 4 compounds in the reaction. Compound A, compound B, reactant A, reactant B, product C, product D. Sorry, 3 compound. We have 2 reactant A and B and 1 product C. So we have 3 row. And don't forget as well, we have an inert. Okay, so kamu ingat, dalam stoichiometric table, asalkan the species is in the reactor, regardless dia involve atau tidak dalam tindak balas, but if they exist in the reactor, it has its own row. Dia ada baris dia sendiri. Sebab tu dalam kes ni, kita ada 4 baris. Baris A and B for the reactant, C is for the product, and 1 row for inert, because inert exists in the reactor. So, kenapa kalau kamu confused, kan table ni kan nak buat mass balance. Okay, so mass balance dia mesti kita kena ambil kira segala mass yang masuk dan juga segala mass yang keluar. Regardless benda tu terlibat atau tidak dalam tindak balas, dia dalam sistem dia ada mass, kamu kena kira the mass inside the stoichiometric table. Just that the mass we calculate in terms of mole, bukan in terms of weight. Okay, right, done on this. Okay, so now you have already 4 row. Let's fill up the row. Okay, so first for A. So for A and A0, you already know, and A0 we calculated as 75. So Na0, 75. Okay, so don't forget, write down and A0, 75 equals to 75. Next, the change for A. So the change of A is a reactant. A will disappear or A will reduce as the reaction goes. So it become minus and A0X. Technically, is minus A per A and A0X. Tetapi A per A is 1. That's why they don't write the A per A, but it's basically 1. Okay, so minus. And A0, you know, is 75. So you replace the Na0 with 75. The X, you don't need to replace because they say we don't know the X. So it's a function of conversion. The X is left as it is. Okay, so change here, minus 75X. Done. Okay, so then go to your remaining. So if your initial is Na0, your remaining is Na. Senang je. Itu beza dia. Initial in Na0. Remaining out Na. So Na equals to, you just copy your initial 75. You combine with your change minus 75x. You get 75 minus 75x. Done. Okay, done. Next one for B. Okay, so B, if you forget, dia ada formula kan? So B, formula for the initial, and B0, we want to find NB0. Kalau A is Na0, kalau B, NB0, initial moles of B. So NB0 equals to, the formula says theta B multiply with Na0. So theta B, you have learned before, but if you forget, senang je konsep dia. Theta B is the ratio of how much B over how much A initially in the system. So how much ni depends on the question. Are you given in terms of concentration ke, number of moles ke, you are given in terms of mole fraction ke, it depends. Okay, dalam soalan ni we are given in terms of mole fraction. Kan ingat dia kata initially 50 mole percent A, 25 mole percent B, 25 mole percent inert. So we can calculate theta B based on this mole fraction. So theta B equals to mesti B terhadap A. So Y B0, initial mole fraction of B over initial mole fraction of A. So 0.25 divided by 0.5, you get 0.5, half lah kan. So theta B 0.5 multiply with your Na0 yang kita dah tahu. So you get NB0 as 37.5. Ataupun basically kata, asalnya the reaction is between 75 mole of A and 37.5 mole of B. Okay, then go to change. So in this case, again, B is a reactant. So B, konsep dia pemahaman bila B adalah reactant, B will disappear ataupun B will be consumed in the reaction. So the number moles of B will decrease, dia akan menurun. So that's why it has a negative sign here untuk indicate dia akan berkurangan as the reaction takes place. So minus multiply with B per A and A0 X. So don't forget what's B per A, the stoichiometric coefficient. Okay, you have to look at the chemical equation, tengok untuk tahu berapa B per A dia. So in this case, the B per A is 1 over 2. Okay, so negative 1 over 2 multiply with your Na0 75 multiply with your X, you get negative 37.5X. So basically that's how much your B will be consumed in the reaction. So done on the change, you go to the remaining, senang sajalah, kamu copy sahaja initial 37.5, copy combine your remaining minus 37.5x, you get your remaining for B. So now kamu dah tahu, you already know how much B are left after the reaction has taken place. Done. You go to C. Okay, so C, product. C is a product, right? So of course, initially, as C is a product, we will not have initial moles of C because C is not formed yet. So NC0 0. Okay, kenapa NC0 0? As I told you, C product initially dia belum terbentuk, it's not yet formed, they won't have any moles. So NC0 0. Then change for C. So change for C, in this case C is a product, so C will be added to the system because C will be added to the reactor because C will be produced, right? So bilangan mol C akan bertambah sebab C akan dihasilkan. So it become plus C per A and A0 X. So again, stoichiometric coefficient ni jangan lupa because most of the time part ni yang student tersalah tengok stoichiometric coefficient. So from the equation, C is 2, A is also 2. So become plus 2 over 2 multiply with 75 multiply with X. You get 75x. So the plus you want to write or you don't write is also okay because positive without writing it is understandable, it means a positive. So NC equals to, since remaining initial 0, you just take the change, so becomes 75x. NC equals to 75x. So last one, inert. So part ni memang not I say most, there are tendency for student to forget that if they are inert in the system, kamu kena ada kira juga dalam table dia. Okay, so we want to calculate initial amount of inert ataupun initial moles of inert. So it's Ni naught equals to theta I and A naught. Kalau tadi NB naught, theta B and A naught. Kalau Ni naught, theta I and A naught. Okay, so how to calculate theta I? Okay, kalau tadi theta B, amount of B over A. Kalau theta I, amount of inert over amount of A. So same case, in this question, they give us in terms of mole fraction. Okay, so we use that mole fraction to calculate your theta I. So it will be Yi naught, initial fraction of inert, over initial fraction of A. So the Yi naught was 0.25 because this is 25 mole percent inert. So 0.25 divided by Ya naught 0.5 because they say 50 mole percent A. So you divide, you get Yi naught equally the same 0.5. So you replace theta I 0.5, Na naught 75, you get your Ni naught 37.5. So initially awal tu ada juga 37.5 mole of your inert in the system. Then we go change. So part ni kamu kena faham lah, inert. That's why they call it inert. It is in the system or in the reactor, but it will not be involved in the reaction. Okay, kamu tengok dalam persamaan kimia tak ada inert ni sebab dia tak terlibat tindak balas. So of course there's no change for the inert. They will not be consumed, they will not be produced as well. So there's no change, right? So you can put dash or you put zero, is understandable, but you have to put something. Jangan biar blank je. Kalau blank, it doesn't imply that you understand. Dia adalah tak ada perubahan. Either dash or you put zero. Okay. Then you calculate the total inert remaining. So total inert remaining, naturally it will be equal to total inert initial because nothing happens, right, to it. So Ni is 37.5. So lastly, what you do? The last row, total initial, total remaining. So nak cari total initial, you just add Ne naught plus Nb naught plus Ni naught. You get 150. And the total remaining, don't forget, total remaining ni a bit complex sebab you got numbers, you got x. So the x's are calculated together, the numbers are calculated together. So dalam kes ni, 75 plus 37.5 plus another 37.5, you get 150. Then kamu kira part x, minus 75x plus another negative 37.5x plus with 75x. Essentially, you get minus negative 37.5x. So you're done for your total initial, total remaining, and you are done for the entire table. Okay, so again, I give you about 1-2 minutes. Okay, this is a little bit long punya question, right? So try to understand and see. Then I will come back in 2 minutes. Then we go to part B of the questions. Okay, so done for part A. So let's go to part B. So part B kamu tengok soalan dia dah panjang sikit. So the part B, this is calculate the formation. Sekejap, saya besarkan. Hold on. Calculate the formation rate of B at 600 Kelvin for conversion of A of 40%. Okay. So first ayat, apa sebenarnya dia kata? Okay, first apa dia kata? Dia nak kita kira, what do they want us to calculate? The formation rate of B. Okay, so ingatkan tadi kita pernah buat kan, rate of formation is positive R. So they want us to find for B. So dia nak kita cari positive RB. So dia nak kita cari positive RB dengan this is conversion 40%, meaning our X is 0.4. Nak cari positive RB kalau X 0.4. Then it says, given reaction rate constant 0.495 at 400 Kelvin. Okay, so dia kita nilai K. Tetapi dia kata nilai K ni yang 0.495 ni is at 400 Kelvin. Okay, itu kamu kena ingat. Kamu kena be very sensitive about this information. They do give us the K, but the K is at 400 Kelvin. Okay, right. Next, they give us activation energy 2.5 kilocalorie per mole. Okay, so let's say, I understand. Engineering question, dia part yang paling susah ialah kita tak tahu nak start kat mana. Lagi-lagi when you have a lot of information, you do not know where to start, which is very, very normal in engineering question. Not even engineering question, even when you work in the next time when you go to the industry, it's also a problem. When you want to solve a problem, let's say you have any troubleshooting in the plant, where do you start? Okay, so the same concept can be applied. You must first know what do you want to find or what do you want to solve. Okay, so macam soalan ni contohnya dia nak kita cari positive RB. Okay, so dia tahu dia nak kita cari positive RB. Okay, so you go and look. Okay, so kamu kena ingat. Okay, kita nak cari positive RB, kamu kena ingat. Okay, how do we find positive RB? Okay, so what happened? I taught you baru tadi that kalau kita nak cari rate of reaction of any other species, rate of formation ke, rate of disappearance ke, untuk any other species, kita tak boleh cari selagi kita tak ada minus RE. So maksudnya, nak cari positive RB, I have to first find minus RE. Sebab rate law tu mesti berdasarkan minus RE. Okay. So second step kamu tahu nak dapat positive RB, saya kena cari minus RA dulu. Okay, so next thing to find minus RA. Okay, so to find minus RA, if you remember kita ikut rate law yang kita dah pernah belajar. We relearn. Kita boleh cari minus RA ikut rate law. So rate law dia kata minus RA equals to K. Tapi K ni be very careful sebab the K must be at your reaction temperature or the temperature of which your reactor is running the reaction. So kalau kamu perasan dalam kes ni dikata pada 600 Kelvin. Meaning my K must be at 600 Kelvin. Sebenarnya nak kita cari the rate of formation at 600 Kelvin. Okay, so the K is K600. Kamu tulis dulu, kamu indicate dulu yang kamu faham. The K tu mesti K pada 600 Celsius. Okay, then rate law dia pula. Okay, order reaction order dia. So kamu kena check. In this question, dia beritahu, rate law dia beritahu. Okay, dia kata second order with respect to A, zero order with respect to B. So technically, CA power of 2 sebab second order with respect to A. Then CB power 0. So kalau kamu ingat, nombor kalau kuasa kosong dia sama dengan 1. Maksudnya 4 power of 0 is 4. Okay, so kita tak tulis dah. Kita tak tulis part CB itu. So become now the rate law as the rate law become minus RA equals to K C So K CA power of 2. CB power 0 tu kita dah tak tulis. Okay, so jadi K CA kuasa 2, the K at 600 Celsius. 600 Kelvin, sorry. Okay. So now kamu dah deduce rate law dia sebenarnya as shown in this rates, the one that I highlighted. So kita carilah one by one dulu kan. Okay, so nak cari minus RA, kita tahu kita kena cari K, kita kena cari CA, kita kena kuasa 2 kan. Okay, so first of all K. Okay, now K. Do you realize from the question, The K is given 0.495, tetapi dia kata K ni is at 400 Kelvin. Your reaction is at 600 Kelvin. Maka you have to find the K at 600 Kelvin. Okay, maknanya kita tahu K pada 400, kita nak cari K pada 600. Okay, so if you remember, Arrhenius ada dua version. Okay, soalan yang kita solve sebelum ni, kita guna yang original version kan. Original version yang kata K equals to, I go to question part 2 kejap. Question part 2 kata, kita guna Arrhenius dia, K sama dengan A exponential minus EA per RT. Okay, you may think that, okay, maybe we can use this. Sebab kita tahu temperature, kita tahu activation energy. However, if you realize dalam soalan number 3, they didn't give us the pre-exponential factor. Dia tak beri kita nilai A sebenarnya. So, kalau kita nak guna original version of the equation, nak cari K, we have to know 3 information. Temperature, activation energy, pre-exponential factor. Tak ada tiga-tiga ni, you cannot find the K. So, in this question, so happen, dia beri EA. Kita tahu temperature, but we don't know our A. So, what do? That's why we have the second version of the Arrhenius equation. Version kedua. Version kedua, kalau kamu ingat, saya ajar kamu. If I know K1 at T1, I can find my new K at T2. Sebenarnya saya tahu K1, saya tahu T1, saya tahu T2, saya boleh cari K2. So, formula dia diberi as K2, left hand side is K2, K at 600 Kelvin lah, K yang pada suhu baru saya, equals to K at 400 Kelvin or K at my original temperature, exponential again, tapi exponential ni dalam ni kamu jangan lupa dah tak ada negatif. It straight away become exponential EA per R in bracket 1 per T1 minus 1 per T2. Okay, so kalau kamu tak familiar dengan formula ni, you check chapter 3, formula dia. It says K2 equals to K1 exponential EA per R in bracket 1 per T1 minus 1 per T2. Okay, so I want to find my new K at 600 Kelvin. So become equals to K at 400 Kelvin, 0.495. Sebab dia kata pada suhu 400 Kelvin, my K is 0.495. So I replace 0.495. Then exponential in bracket EA per R. So again, dalam kes ni, EA dia is in calorie per mole, kilocalorie per mole. So convert to calorie per mole, multiply with 1000. So 2.5 kilocalorie per mole become 2500 calorie per mole. Divide by R. Okay, so the R, kalau calorie, the R is 1.987 calorie per mole Kelvin. Okay, in bracket, don't forget, dia adalah 1 per T1 tolak 1 per T2. So 1 per 400 Kelvin minus 1 per 600 Kelvin. Okay, so when you do this calculation, again nanti bila saya bagi masa sikit, kamu try calculate sebab memang saya perasan most of the time student boleh ganti nombor yang betul tetapi jawapan akhir tak dapat. So please make sure you practice pressing your calculator as well so that you know how to press the calculator. Then you should get your K as 600 as 1.412. So again, a way for you to check betul atau tidak calculation kamu. Kamu banding K pada 600 dengan K at 400. Technically, theoretically and by right, K at 600 Kelvin must be bigger than K at 400 Kelvin. So kalau kamu tengok at 400 the K was 0.495. At 600 the K is 1.412. So kamu tengok ada peningkatan, most likely your answer is correct. However, katakan kalau kamu kira K600 tu lebih kecil, you go and check. Definitely there are some errors in the calculation sebab K will increase with temperature. Okay, so dan kamu dah cari K. Okay. Kita cari mana side A kan? So K kita dah cari. Next is CA, outlet concentration of A. So if you realize in this question, soalan yang sebelumnya, outlet concentration is given directly. In this question, outlet concentration is not given. Means CA tu kita tak tahu, but we need to find. Okay, so happen. Chapter 3 kan kamu dah belajar. Kita kan dah belajar how to express concentration. That's why we do the table. We do the table to express the concentration. So how to express for A? So outlet concentration of A equals to outlet moles of A divided by reactor volume. Ca sama dengan Na per reactor volume V. Okay, how do you find Na? So Na, the remaining moles of A, tengoklah stoichiometric table. Stoichiometric table dah kata Na equals to 75 minus 75x. So ganti sahaja Na 75 minus 75x divided by the reactor volume. Reactor volume given as 15 liter. Dah beritahu. The reactor volume 15 liter. Then dalam soalan ni, X is already given. Dalam table kita tak tahu nilai X, right? So the X is left as it is. However, dalam part B, we already know the X is 0.4. So you replace the X with 0.4. Okay, you calculate, you will get your Ca as 3 mole per liter. So kita dah tahu dah berapa concentration A. So done. Kita dah tahu K, kita dah tahu Ca. You can already calculate your minus Ra. So minus Ra equals to K at 600, 1.412 multiply with Ca 3. Don't forget power of 2 sebab dia kan second order with respect to A. So Ca kena kuasa 2. You multiply, you get 12.708. So that's your minus Ra. You cannot stop here because yang kita nak cari adalah rate of formation of B. Kita nak cari positive Rb. What you have done so far is just to find minus Ra. So keluarkan balik perkaitan dia. So positive Rb, rate of formation of B. However, in this reaction, B is a reactant. Nak cari rate of formation of B. However, B is a reactant, B disappear. So nak cari kadar pembentukan tetapi B hilang, it doesn't agree to one another. That's why the number has a negative sign in front of it. So negative. Multiply, don't forget stoichiometric coefficient B per A. Jangan lupa stoichiometric coefficient tu mesti ada. Perkadaran stoichiometric tu mesti ada. So B per A multiply with your minus Ra, the one that you calculated just now. So B per A, please make sure you check stoichiometric coefficient. B is 1, A is 2. So that's how it become negative 1 over 2. Multiply with 12.708, your minus Ra. You will get your positive Rb as negative 6.354 mole per liter minute. So again, kenapa nombor tu negatif? Sebab nak cari kadar pembentukan B, tetapi B hilang because B is a reactant. That's why nombor tu akan jadi negatif. Okay, so done for question number 3. So I give you a little bit longer break. So soalan ni panjang pengiraan dia. So I'll come back about in 2 or 3 minutes time. Okay, alright. Okay, done. So we are done with question number 3. Okay, so for your homework, okay, when you have extra time, you please attempt question number 4 by yourself. So question number 4 is a little bit challenging. So I would like you to try by yourself. As usual, find the answer memang ada dalam soalan. Try to see whether can you do question number 4 on your own. So if you can do question number 4 on your own, by right means you are ready for exam, means not ready for exam lah, means you understand the concept of doing stoichiometric table for batch reactor. Okay, so again repeat, question 4 saya takkan discuss, okay, but of course you try. If you cannot get the final answer as what is given in the question, you may refer to me, okay, tapi I would like you to try it by yourself later on when you have extra time. Okay, so question nombor 4 ni susah sikit sebenarnya, bukanlah susah sikit, a little bit challenging. So kamu tengok kamu faham ke tak, sebab kalau kamu dah you understand the notes, you understand the question, you understand yang tadi yang saya discuss question number 3, you should be able to do question number 4. The key is betul-betul faham information dan betul-betul tahu apa yang dia nak cari. Okay, alright, so saya skip question number 4, it becomes a homework for you as your additional extra soalan lah. Okay, so I go to question number 5. Okay, so question number 5 sekarang kita dah pergi flow reactor. Okay, so tadi soalan masih batch reactor. Now questions I go to flow reactor. Okay, so whenever you see question table ke, concentration ke, kalau dah flow reactor, CSTR or PFR tu flow reactor, you have to be very careful about the phase. Okay, adakah dia liquid phase atau gas phase? Okay, itu yang part yang kamu kena betul-betul tangkap. Kalau dah flow reactor, tengok dia liquid phase ke gas phase. Okay, so let us go to this question. The question says, the liquid phase reaction in a flow reactor at 150 Celsius is given as A reacting with 2B to produce 2C. Okay, so apa information dia beri? First, dia kata liquid phase. Kedua, this is flow reactor. So kalau kamu tengok soalan kata flow reactor, CSTR ke, PFR ke, means the stoichiometric table is in the form of molar flow rate. Or more exact, kamu kena tahu dulu initial molar flow rate of A, FA0. Kalau tadi batch reactor, kamu kena cari NA0 dulu. Tak ada NA0, tak boleh buat table. Kalau flow reactor, kalau tak ada FA0, kamu tak boleh buat table. So make sure you know table tu mesti tahu FA0 baru start buat table. Tak diberi, you cannot start. Alright, okay, so done. Next dia kata 150 Celsius. So maksud kamu kena faham, nanti kalau ada sebarang pengiraan yang ada melibatkan K tu mesti pada 150 Celsius. Okay, maksudnya kalau kamu nak kira minus RA itu ada K kan? K tu measure must be at 150 Celsius. Okay, sebab dia mesti dikira pada suhu tindak balas. Okay, done. Next, dia kata initial concentration of A and B are 1.8 mole per dm cube and 5.4 mole per dm cube respectively. So they give us the initial amount, tapi initial amount dalam bentuk concentration. So they tell us CA0 1.8, CB0 5.4. Okay, again I repeat. They give us CA0 1.8, CB0 5.4. CB0 apa? Initial concentration of B. CA0 initial concentration of A. So CA0, CB0 dah diberi. Okay. Next dia kata initial with an initial rate of 10 dm cube per minute. Okay. So tadi yang 1.8, 5.4 tu kamu tahu concentration. Kamu takkan confuse bila dia kata concentration. Tapi dia kata bagi information lagi, dia beri kita initial rate 10 dm cube per minute. So again, dm cube per minute change to dimension dm cube volume minute time. Volume per time, volumetric flow rate. Then volumetric flow rate pun as you know ada initial, ada final. Dia kata sini initial. So this is initial volumetric flow rate. Epsilon naught. Okay, so epsilon naught diberi 10 dm cube per minute as I shown in the red punya tulisan. So CA0 1.8, CB0 5.4, epsilon naught 10 dm cube per minute. So again, katakanlah 3 information ni kamu salah identify. Katakan kamu ingat yang 1.8 ni FA naught. The whole question dah salah. Or you thought that 10 dm cube per minute tu adalah FA naught. The whole question is wrong. So don't make this mistake. Betul-betul tengok nombor, tengok unit, convert dimension. Dan kamu akan tahu betul tak itu nilai yang perlu saya gunakan dalam soalan saya. Okay, done. Next dia kata, given specific reaction rate constant of 1.7 at 100 Celsius. So dia beri kita K, reaction rate constant kan, K 1.7. Tetapi this 1.7 is at 100 Celsius. So although we are given the K, but our K is at 100 Celsius. So you don't forget, suhu tindak balas kita, our reaction occurs at 150 Celsius. Okay, walaupun kita ada nilai K, tetapi nilai K yang diberi bukan pada suhu tindak balas kita. Okay, so that is important part yang kamu kena ingat. Kalau diberi nilai K, tengok pada suhu apa. Adakah itu suhu tindak balas ke tidak? Kalau it's not, then you have to remember, means saya dah kena cari K pada suhu 150, 150, the reaction temperature. Okay, then it says activation energy 5 kilocalorie per mole. So dia beri kita EA. So dia beri kita EA 5 kilocalorie per mole. And they says the reaction obeys elementary rate law. So question ni kata dia obeys elementary rate law, meaning reaction order of the reactant follows the stoichiometric coefficient. So means the reaction is first order with respect to A, second order with respect to B. Terus tahu dah, terus tengok stoichiometric coefficient, terus tahu dia punya reaction order. Done. So that's all so far that we know. So we go to the question first. A. Construct a stoichiometric table for the reaction. All values should be in the function of conversion only by numerically evaluating all other symbol. Okay, so dia kata dalam soalan ni, dia suruh kita buat stoichiometric table. Okay, dan samanya konsep. Because we don't know our conversion, so kita tinggalkan saja X2. The rest must be in terms of numbers. Okay, so that's important. Okay, so again, to start a table. So to start a table for flow reactor, macam saya kata, if you have not yet know your FE naught, you cannot start the table. Mesti salah. Kalau kamu start table guna CE naught ke, guna epsilon naught ke, confirm table tu mesti salah. Selagi tak tahu FE naught, tak boleh cari. Okay. So then lepas tu kamu kena faham lah FE naught tu apa. Molar flow rate of A initially. So kalau molar flow rate, dia mesti mole per time. So saya kena cari nilai yang ada unit mole per time. Selagi tak ada nilai unit mole per time, memang salah lah jawapan saya. Okay, so again, macam nak cari? So kalau kamu ingat tadi, kalau kita nak cari NA naught equals to CA naught multiply with V naught. Itu adalah untuk batch. So kalau flow reactor, dia akan menjadi FA naught equals to CA naught multiply with epsilon naught. Kalau tadi bilangan mole sama dengan concentration multiply dengan volume. Kalau flow, molar flow rate sama dengan concentration multiply dengan volumetric flow rate. So itu je perbezaan dia. So kita dah tahu concentration A initially 1.8. Volumetric flow rate initially 10. So again, kalau kamu tak pasti darab ke bahagi, you are not sure multiplication or division, you just do unit cancellation. Itu cara yang paling senang. Kalau you realize in this question, I can only cancel my unit dm cube. I have 1 dm cube at the bottom, 1 dm cube at the top. I can cancel. I'm left with mole per minute. So mole per minute, dimension dia mole per time, molar flow rate. So most likely betul lah nilai yang kamu kira tu adalah molar flow rate. So you get 18 mole per minute. But don't forget, kamu kena multiply CA naught. Okay, dia beri kita CA naught, dia beri kita CB naught. Make sure nak cari FA naught, mestilah kena multiply dengan CA naught. So you get your FA naught as 18 mole per minute. Now that you have obtained the mole FA naught, then you can start doing the table. Okay, then you have to check dalam table ni ada berapa row dia. Okay, so first of all, dalam tindak balas ni, we only have 3 compounds in the reaction. 2 reactant A and B, 1 product C. So and you also realize in the question, They did not mention anything about inert ke or any other compound selain daripada A, B and C. So if is that the case, so you only have 3 rows sahajalah, 3 baris sahaja untuk 2 reactant and 1 product. You don't need a row for the inert sebab tak ada inert ataupun tak ada sebarang compound inert in the system during the reaction. Okay, next. Unit dalam stoichiometric table. In this question, FA0 is in the form of mole per minute. So make sure all your initial, your change, your remaining, letaklah unit dia mole per minute. Okay, then you start doing the table. Okay, so table dia, saya rasa saya tak discuss lah sebab table dia straightforward kan. Pemahaman dia masih sama. Just that tadi kita guna NA0, sekarang kita guna FA0. Okay, tapi mungkin I will discuss one thing. Kita nak cari theta B. Sebab nak cari FB0, we need to find theta B FA0, right? Okay, so how do you find theta B? So as I told you, konsep dia sama macam batch. Dia masih ratio of initial amount of B terhadap E. So initial amount ni dia boleh jadi depends on the question. Like previous one, they give us mole fraction. In this question, they didn't give us mole fraction. However, they do give us the initial concentration. Dia beritahu kita initial concentration of A 1.8, initial concentration of B 5.4. So initial concentration ni pun kita boleh guna untuk calculate theta B. So it become CB0 per CA0. So tadi kalau soalan yang kedua, soalan ketiga, kita guna YB0 per YA0, mole fraction. Dalam soalan ni, kita guna concentration pula sebab dia beri kita information dalam bentuk concentration. So CB0 divided by CA0, so you get 5.4 divided by 1.8, you get 3. So your theta B is 3. So the rest sama je konsep dia sebab dalam kes ni pun B adalah reactant. So sama konsep dia, you calculate. So when you have extra time later or other day, you try to do by your own. You should be able to get nak tahu sama ada betul atau tidak kamu punya table. Kamu tengok je total remaining dengan total initial. Kalau total remaining, total initial ni sama dengan jawapan yang saya bagi, betul lah. Okay, it definitely be correct. If your total initial, total remaining in your table is the same as the final answer in my question, means you do the table correctly dah. Okay, so done for the table. Okay, sebab table tu, sebenarnya table ni tak susah. Just that normally kalau student tak boleh buat sebab dia tak cari FA0 atau dia salah interpret information. So dia letak FA0 yang salah. So memang complete table tu salah lah in that concept lah. Right? Okay, done. So I will go to the part B. Part B yang kita nak fokus sikit. Okay, part B dia kata, determine the rate of disappearance of A if the conversion is given as 80%. So dia nak kita cari apa? Rate of disappearance of A minus RA. Okay, so dia nak kita cari minus RA and dia beritahu kita, they tell us the X is now 80%. X 0.8. So kalau nak cari minus RA, direct lah kan sebab rate law kita memang kita nak cari terus minus RA. So kamu derive dulu rate law dia, macam mana kita nak dapatkan minus RA. So dalam soalan, dia kata, first of all, rate law kata minus RA equals to K. Tapi K tu kamu kena betul-betul check. You really need to check. The K must be at your reaction temperature. Okay, in this question, the reaction temperature is 150 Celsius. Hence, the K must be at 150 Celsius. You better indicate. Kamu dah kena indicate dalam kamu punya penyelesaian. K tu pada suhu apa? So that you won't make the mistake in the calculation. Because you know, K mesti ikut suhu tindak balas. Okay, so you write K subscript 150 means K pada 150 Celsius. Then, the concentration, reaction order dia. Since this is follows elementary rate law, so dia kata it follows elementary rate law. So reaction order with respect to A is first order. Reaction order with respect to B is second order. That's why you get K, CA, CB power of 2. CA power 1, CB power 2. Okay, so you write like this. So now you're right. So now you have to find one by one. So first of all, K. So dalam soalan ni kamu kena betul-betul check. Walaupun nilai K diberi macam soalan nombor 3, tetapi this K is given at the K was given at 100 Celsius. This 1.7, your K is at 100 Celsius. However, your reaction is at 150 Celsius. You have to find the new K. So, dia punya formula adalah K2 equals to K1. exponential EA per R in bracket 1 per T1 minus 1 per T2. Okay, so dia minus 1 per T1 tolak 1 per T2. Or in other word, 1 per suhu asal tengok tolak 1 over the suhu baru yang you want to find the K. Okay, so you just calculate the new K at 150. So make sure you practice this as well. Okay, so you find the new K. So you will get the new K as 3.7714. So part ni, okay, kalau kamu nak check senang saja. Nilai K meningkat dengan suhu. Originally, the K was 1.7 at 100 Celsius. And at 150, you get the K 3.7714. Most likely, jawapan kamu adalah betul sebab K kamu meningkat dengan suhu. Okay, if you ever wonder, bila I talk about K increase with temperature, you got few example kan? Kamu perasan kadang-kadang kenapa K tu naik sikit? Kadang-kadang K tu naik dengan banyak walaupun suhu dia tak jauh beza. It's because this one is depend on activation energy. The bigger the activation energy, lebih besarlah peningkatan nilai K tu ataupun lebih besarlah beza nilai K. Tetapi kalau your activation energy kalau activation energy kamu kecil, maka perbezaan K tu tak banyak. Okay, so that's only different. Kenapa kadang kamu tengok naik suhu sikit, nilai K naik banyak. Ada question suhu naik sama juga tapi nilai K tu naik banyak. So it depends on the activation energy sebenarnya. Lebih tinggi activation energy, the higher the K will increase actually. Okay, so done. To find the K at 150, so dah habis kan? Kita dah cari K 150. Now kita nak cari CA, CB. So CA, CB dalam soalan ni pun sama. They did not give us directly. However, you know you can use the table to find your CA and CB. However, dah berubah sikit. Tadi kalau batch reactor, kamu nak cari CA, you want to find CA from the batch reactor, it was CA equals to NA per volume, V. However, for flow reactor, CA sama dengan molar flow rate of A, FA over epsilon, which is the volumetric flow rate. So, konsep dia kalau batch, mole per volume. Kalau flow, molar flow rate per volumetric flow rate. Itu je beza dia. Maksudnya, mole per time bahagi dengan volume per time. Okay, so you know, nak cari the FA, the outlets or the remaining moles of A, FA, gunalah table. Table dah beritahu dah. FA equals to 18 minus 18x. So maksudnya, if you are done the table, you will know that your FA is 18 minus 18x. So you just replace 18 minus 18x. X is 0.8. So I can really replace my x as 0.8. Done. Then divide by volumetric flow rate. Okay, part ni yang kamu kena faham sikit. Okay. In this example, this is outlet volumetric flow rate. Okay, so kamu dah pernah belajar kan, saya beritahu kamu untuk liquid phase flow reactor, okay, CSDR, PFR. For flow reactor, volumetric flow rate, inlet dengan outlet ni, dia bergantung kepada inlet outlet volumetric flow rate. It depends on, are you talking about liquid phase or gas phase reaction? If it's if it's liquid phase reaction, inlet outlet volumetric flow rate is equal. Means kalau you pump in 100 liter per minute of liquid, yang keluar pun masih 100 liter per minute of liquid. Only for liquid sahaja dia sama. Kalau gas dah tak sama kan, saya ajar kamu kan, kalau gas dia dah tak sama kan, so part gas tu kamu kena ingat dia dah tak sama inlet outlet. Tapi kalau liquid dia sama. Okay, so that's why we can replace the outlet volumetric flow rate as 10. Okay, so kita dah ganti dengan 10, we ganti the X, you get your CA as 0.36. Outlet concentration of A is 0.36. So, do similarly for FCB. So, kalau tadi CA, FA per epsilon. Kalau CB, FB over epsilon. Epsilon tu masih sama. Yang berubah adalah molar flow rate. Sekarang jadi molar flow rate B. So, the outlet or the remaining molar flow rate of B, you just look at the table again. So, from the table, FB equals to 54 minus 36x. Again, FB equals to 54 minus 36x. So you replace your FB as 54 minus 36x. The x you replace with 0.8. You divide by your outlet volumetric flow rate 10. You get your CB 2.52. So now you already got your K at 150. You got your CA, you got your CB. You can now find your minus RA directly. So minus RA equals to, replace your K, 3.7714. Replace your CA, 0.36. Replace your CB, but don't forget power of 2 sebab dia second order with respect to B. So you replace 2.52 power of 2, you get the final answer as 8.6220. Okay, so this is the rate of disappearance of A at 150 Celsius. Okay, so I give you again as usual 2 to 3 minute time for you to digest this. Okay, so before I go to the next question, all right, I'll come back. Right, so we go one more question, then we are done for today. We try one more question. Okay, then we are done for today. We will continue on Wednesday. Okay, so the second last question, soalan nombor 6. Okay, let me see. Okay, sikit, tak banyak sangat. Okay, right. Okay, so question number 6. Okay, sekarang we do the following is the gas phase pyrolysis of reactant A and B to produce product C. Okay, so sekarang dia kata, first of all, ada few information yang kamu kena faham. First, dia kata gas phase pyrolysis. So, sebabnya tidak balas ni adalah gas phase reaction already. Okay, so gas phase kamu kena betul-betul berjaga because you know for gas phase flow reactor, konsep dia dah berbeza sedikit. So, we have to be very careful about that. Second, dia kata reactant A, reactant B produce product C. So, reaction dia 1A reacting with 2B to produce 1C. Done. So next dia kata, the irreversible reaction occurs isobarically and isothermally in a flow system with 80% mole A and the remainder reactant B. Okay, so dalam soalan ni pun ada banyak information dia bagi. Dalam ayat kedua dia kata, first, irreversible. Okay, so dalam setakat sampai chapter 4 ni kamu hanya belajar we still learn irreversible, tindak balas yang tak berbalik. Okay, so later end of chapter 4 you will learn reversible. So kalau reversible kamu dah kena faham konsep dia pun dah berlainan. Okay, so that's one thing. Second, isobaric isothermal. So maksudnya constant pressure, constant temperature, or we can say T equals to T naught. Inlet outlet temperature is equal, no change, and P equals to P naught means no change in pressure as well. P equals to P naught, T equals to T naught. Okay, next one dia kata 80 mole flow system. So ni adalah gas phase flow reactor. Okay, next dia kata 80 mole percent A, remainder reactant B. So means initially I only have two compound, two reactant, tak ada inert. Ni pun case ni pun tak ada inert. Dia ada A, ada B, and mole percent dia 80 mole percent A, YA0 0.8, maka YB0 0.2. So whenever you are given the initial amount, kamu dah terus tahu tu mesti nak cari theta B. Definitely to find theta B. If you are given the initial amount of A, initial amount of B, nak cari your theta B in your table. Okay, next dia kata reaction is second order with respect to A and zero order with respect to B. So again, dalam soalan ni dia terus beri kita reaction order dia. So dia beri kita reaction order, meaning this reaction is non-elementary lah. Sebab hanya non-elementary, the information has to be given to you. So the reaction order is actually second order with A, zero order with respect to B. So tu adalah untuk rate law dia lah. Kita dah tahu macam mana rate law dia. Next dia kata, the total feed rate of A is 108 million gram yearly. So apa information ni? Macam something different, right? So, sebelum ni kita deal dengan concentration, molar flow rate, volumetric flow rate. This one is another new information. Dia kata feed rate. Okay, so ni adalah kadar suapan lah, feed. So initial rate dia diberi million gram yearly. Okay, so kamu tahulah kalau gram dimension dia mass, yearly tu time, right? Okay, so basically dia beri kita mass per time. Okay, so mass per time, kalau kamu faham apa tu mass per time? Mass per time is mass flow rate. So dia beri kita sebenarnya mass flow rate of A initially. So sebelum ni kamu belajar, saya ajar kamu volumetric flow rate, molar flow rate, concentration, number of moles. But I never touch mass flow rate dalam soalan kita, dalam apa yang saya ajar sebelum ni. So now they give us mass flow rate. Okay, so they give us mass flow rate of A as 108 million gram yearly. Ataupun we can say kalau mass flow rate kita guna M. Mass flow rate we use M. So dia beri kita MA0. MA0 as 108 times 10 power of 6 million gram per year. Okay, kita convert. Gram yearly tu maksudnya untuk setiap tahun dia akan guna 108 million gram per year. Dia beri kita mass flow rate. Okay, so MA0. Kita letak sebagai MA0 108 million gram per year. So done. That's the information that we know so far. Next, dia beri kita initial volumetric flow rate. Okay, this is epsilon naught. Epsilon naught 5 dn cube per minute. So we know epsilon naught 5 dn cube per minute. They give us the K 3 dn cube per mole minute. In this question, the K is not specified at which temperature. Okay, so kalau ada question, hold on kejap saya punya, I will come back in 1 minute. Hold on Okay, back to the question. Okay, so now they give us, although they give us the value of K, but they didn't specify at what temperature. So kalau dia tak specify pada suhu apa, it is safe for you to assume dia adalah pada suhu tindak balas. Okay, again I repeat, if they did not specify this K is at what temperature, it is okay for you to assume it is the K is at your reaction temperature. Means, arti kata lain, kamu dah tak payah cari K yang baru ataupun K pada suhu tindak balas. You are right to assume dia adalah pada suhu tindak balas kamu. Okay, done. Next, they give us molecular weight. So, kamu tahu kan molecular weight, arti you know by now apa tu molecular weight. So, molecular weight of A is 30 gram per mole. Okay, next, dia kata, the plant operates 20 hours daily for 300 days annually. Sekarang ni beritahu kita pula. Plant kita tu, the plant, you see that your plant is working every day for 20 hours for each day, and for every year is only operating for 300 days. Okay, so what do we do with this information? Tak apa, kita tengok dulu apa soalan tu nak. So the question says dia nak determine the initial molar flow rate of A in mole per minute. So dia nak kita cari molar flow rate A initially. Dia nak kita cari FA0. Okay, so dia nak kita cari FA0. Okay, so first of all, dia dah beritahu kita juga FA0 tu unit dia mesti mole per minute. Okay, means basically whatever that you have, jawapan akhir tu mesti dalam bentuk mole per minute. So how do we do this? Okay, so how do we start this? So sebelum ni, kalau soalan sebelumnya, if you are familiar, kita boleh cari FA0 kan? If we know CA0, we know epsilon naught. Dalam soalan ni, we do have epsilon naught, which is 5 dn³ per minute. Okay, right. Epsilon naught tahu. Tapi kita tak tahu CA0. We are not given any information about the concentration. There are no other numbers yang ada unit mole per volume if you realize. So means tak ada CA0. So you are stuck. Sekarang tak ada CA0, tak boleh cari juga. Okay, so how do I do this? I know saya nak cari mole per minute. Saya kena ada information ada mole per minute. Okay, so the only one else information which is possible for you to use is the 108 million gram yearly. So kita tahu initial mass flow rate, halaju jisim, halaju berat A initially is 108 million gram per year. So kita ada gram per year. Tapi kita nak cari FA0 tu dalam bentuk mole per minute. So you have two challenges, right? Dimension mole dengan mass tak betul, 1 gram, 1 mole tu cabaran pertama. Cabaran kedua, time tu pun tak, unit dia tak konsisten. 1 year, 1 adalah minute. So kita kena tukar dua-dua benda. So first of all, yang penting kita nak tukar daripada mass to mole kan, sebab molar flow rate. Kita ada mass flow rate. So how do we change from mass to mole? Okay, so if you realize, if you learn in CPP, which you have, if we want to convert from mass to mole, we can use the molecular weight. So basically, molecular weight is a conversion factor yang boleh menukarkan from mass to mole or mole to mass. Vice versa pun boleh dengan menggunakan molecular weight. Tapi kamu kena fikir, do we divide or do we multiply with molecular weight? Okay, so nak cara yang paling senang, gunalah pembatalan unit sekali lagi. Okay, maksudnya, you know that you will start with the mass flow rate kan, 108 times 10 power 6 gram per year. Okay. You know that ultimate answer mesti mole di atas. Sekarang unit gram saya di atas. Saya nak gram tukar menjadi mole. Okay. So kamu tahu kalau kamu do the unit cancellation, meaning you divide with the molecular weight. So kalau kita bahagi dengan molecular weight dia kan 30 gram per mole. So I will put multiply 30 gram kat bawah, mole di atas sebab kita kena bahagi dengan molecular weight. Let's say kamu tak sure multiply atau divide. Okay, now I try to divide first. Okay, so bila saya divide, so it become 30 gram kat bawah, mole di atas. So you realize if I do this, I can cancel my unit gram. So my unit gram is now cancel. 1 gram di atas, 1 gram di bawah. I can cancel my gram. So I'm left with what? I'm now left with mole per year. So part mole tu dah betul. Dah dapat dah mole. Sebab saya punya ultimate answer must be in mole per minute kan. So mole tu kita dah dapat. Part mole tu dah okay. Tetapi the time is now not yet. Because my time now is in year. But my final answer must be in minute. So I must convert year to minute. However, for you to convert year to minute, you must understand you cannot just convert 1 tahun 365 hari blah 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 because the plant has limitation in terms of the time. Sebab in the plant, for every 1 year, the plant only works 300 days. So conversion factor dia adalah 1 tahun terhadap 300 days. So it become 1 year multiply with 1 year divide by 300 days. Conversion factor dia. Untuk setiap 1 tahun, plant itu will only work for 300 days. So let's say again, kamu confused. Kenapa days di bawah, year di atas? Because again, Saya nak cancel year kan, saya nak dapat minit. Saya nak cancel year. So mestilah kalau year original saya kat bawah, the other year must be at the top. Barulah boleh cancel. So now become, when I cancel this, I only get mole per day. Not yet mole per minute. I still just get mole per day. Okay, then again maksudnya day tu saya kena convert kepada minit. However, to convert the day to minute, I got second limitation because for every 1 day, my plant only work 20 hours. So tambah lagi conversion factor. Setiap 1 hari, plant tu hanya bekerja 20 jam. So when I do this, kamu tengok saya dah boleh cancel day. I already can cancel my day. So now I cancel day, I'm left with hour. So now I'm left with mole per hour. Tak settle lagi sebab kita nak mole per minute kan. Tapi kalau hour per minute tu tak ada limitation lah. For every 1 hour, mestilah 60 minute. So tambah one more conversion factor. For every 1 hour, it's actually 60 minutes. So now I can cancel my hour. So finally, I'm left with mole per minute. So basically means my mass flow rate divide by molecular weight times the conversion factor for day, year to day because of the plant limitation, multiply with another conversion factor from day to hour because my plant only work 20 hours per day. Then convert from day hours to minute, the conventional one lah, 1 hour 60 minute. Then only you get your final FA0 as 10 mole per minute. So soalan ni different from the rest that you have I counted before sebab sebelum ni soalan ni more straightforward bagi concentration, bagi molar flow rate, bagi volumetric flow rate. But this question is a bit different. I give you mass flow rate. So you have to know by yourself how do we convert from mass flow rate kepada molar flow rate. Okay, so we are done for question part A. Nak cari FA0. Okay. Now, second question dia kata, develop a stoichiometric table for above reaction in mole per minute. All values should be in a function of conversion only but evaluating numerically all other symbol. So since part A dah cari FA0, part B disuruh kita buat table. Okay, buat je lah balik table tu. Tapi again, X tak diberi. So the rest are in numbers. The X is left as it is. The rest masih sama. Mungkin satu part yang mungkin kamu confused nak mencari theta B. Tapi theta B pun dah sama kan? Theta B as long as dalam soalan ni they give us initial mole percent of B dan initial mole percent of A. So nak cari theta B jadilah initial mole fraction of B divide by initial mole fraction of A. It was 80% A, 20% B. So theta B akan menjadi 0.2 divide by 0.8, you get 0.25. Once you get your theta B, you can already do the table already. So table ni pun saya tak discuss sebab table ni actually very straightforward. Just that dia hanya susah kalau kamu cari FA0 tu salah ataupun kamu tak cari FA0. Kamu salah ganti, then you'll be wrong. The rest are still the same. So I skip the stoichiometric table part. You should be able to do this by yourself. Again, final answer pun saya dah beri. And in fact, in this video pun you can see already the table is already there. Please make sure you do it by yourself and this part so that you understand better. Okay, I go to the last part. Last part sebenarnya yang penting ataupun last part lah sebenarnya yang susah. Okay, so what do they want to do? They want us to find the rate of formation of B if given the conversion is 40%. Okay, so mungkin kamu tengok soalan dia macam sama. Kenapa lah saya kata susah kan? Okay. Apa part yang senang, apa yang part yang susah? Okay, tak apa. Kita buat dulu soalan dia. The question want us to find rate of formation of B. Dia nak kita cari positive RB. Okay, so ingat kan saya dah kata kalau nak cari kadar tindak balas for other species, tak boleh cari selagi tak tahu minus RA. So kamu cari dulu minus RA, baru kamu fikir pasal positive RB. So let us first find minus RA. So nak cari minus RA ni kena tahu rate law dia. Kita dah belajar kan, kita kena cari rate law dia. So minus RA equals to K. Dia tak kata suhu apa. So kita guna je nilai yang diberi. So K terus. Then dia kata dalam soalan is second order with respect to A. Dia kata second order with respect to A. And zero order with respect to B. So anything yang zero order jadi 1 sebab 4 kuasa kosong adalah 1. 5 kuasa kosong masih 1. So means CB power of 0 become 1. So dalam rate law tu dah tak ada part CB. We only have the part for A is CA power of 2 because second order. So become KCA square. So KCA square done. Okay. Kita nak carilah kan. Okay, first K. K senang lah. K tak payah cari dah sebab K dah diberi. The K is given as K is given as K berapa K is given as 3. So dah cari. K tak payah cari, terus guna K yang diberi. The problem now is cari CA. Yang part yang saya kata susah sebab sekarang to find the CA is no longer the same as previously. Sebab dalam kes yang sebelumnya, CA tu untuk get liquid phase, CA tu sama dengan FA per epsilon, outlet volumetric flow rate. Tetapi sekarang liquid, outlet volumetric flow rate dah tak sama dengan inlet volumetric flow rate. That become the hard part. Okay, so how do we do this? Okay, kita nak cari CA kan? Okay, so CA sama dengan outlet molar flow rate of A divided by outlet volumetric flow rate. Okay, ni sama macam liquid juga. Dia mesti outlet concentration, outlet molar flow rate, outlet volumetric flow rate. The only difference pula sekarang adalah outlet volumetric flow rate ni dah tak sama dengan inlet untuk gas. Again, I repeat, the problem now becomes because the outlet volumetric flow rate of gas is not equal to inlet volumetric flow rate. Kita dah kena cari outlet volumetric flow rate yang baru. Okay, how to find? Okay, so kita buat dulu yang atas. Okay, FA dulu. Okay, FA ni sama. Okay, kita tengok table berapa FA yang kita cari. When you do the table, you will know your FA tu how much. Okay, you will derive, you will get your FA. For example, in this question, the FA is 10 minus 10x. So saya ganti sahaja FA saya 10 minus 10x. I ganti my x with 0.4. So part FA ni memang tak ada beza, sama sebab kita ambil per table. Part yang beza saya kata kamu dengan volumetric flow rate kan, sebab kamu ingat I told you inlet outlet volumetric flow rate untuk gas dah tak sama. Okay, they are given in terms of equation. Ingat saya ajar kamu equation yang paling panjang tu. Equation tu kata for gas phase flow reactor, again gas phase flow reactor, outlet volumetric flow rate equals to inlet volumetric flow rate kalau liquid di stop kat sini. Kalau gas ditambah part yang belakang, part yang 1 plus epsilon x, and technically dia ada yang P0 per P, T per T0. Because in this reaction, isothermal, isobaric. Sebab tu part yang P0 per P jadi 1, T per T0 pun jadi 1. Sebab tu dah tak ada dalam equation kita. So our equation now become outlet volumetric flow rate equals to inlet volumetric flow rate in bracket 1 plus epsilon x. Kita kena cari dulu outlet volumetric flow rate dalam bentuk ini. Okay, so first of all, inlet volumetric flow rate 5. Kita given in the question, the inlet volumetric flow rate is 5 dm cube per minute. So B naught ni, epsilon naught ni settle. Dalam bracket 1 plus epsilon x. So epsilon ni pun kalau kamu ingat ada equation, ada sub-equation lagi. So what is this epsilon? Okay, so saya tahu sekarang dah memang I think it's a bit heavy for you. A little bit more we are done for today. Okay, epsilon. So nak to find epsilon is actually ada sub-equation. Epsilon equals to YA0 sigma. So part ni yang kadang-kadang student akan get very confused. I can really understand sebab dah ada equation, ada sub-equation lagi. So epsilon equals to YA0 sigma. What is YA0? YA0 kamu dah pernah belajar kan? Initial mole fraction of E. Itu YA0 yang biasa. Initial mole fraction of E. Dalam soalan kalau kamu ingat, it says initially 80 mole percent A. So YA0 tu 0.8 lah. Okay, tu tak apa. YA0 saya student faham. Sigma yang jadi masalah sebab sigma pun ada lagi sub-equation. So you have one equation, sub-equation, lagi satu sub-equation. Sigma pula. What sigma? Sigma is the ratio of stoichiometric coefficient. Okay, untuk setiap compound in your reaction. And ratio dia ada positif, ada negatif because it's positive for reactant, positif for product, negatif for reactant. Nisbah stoichiometry itu adalah positif untuk produk dan negatif untuk reactant. So you have to be very careful about this. So dalam contoh ni, we have two reactant, A dan B. Produk dia C. So sigma tu akan sama dengan, will be equal to C per A minus B per A minus A per A, which is 1. Okay, kenapa minus B per A minus A per A? Because A and B is reactant. C per A tu product, C tu product. So jadi plus C per A. So you will replace with the stoichiometric coefficient. C per A will be 1 over 1 minus B per A 2 over 1. Kamu tengok persamaan kimia dia. Nombor di hadapan B adalah 2. So 2 per 1 minus technically A per A, which is 1. Okay, so when you calculate this, you will get your epsilon as negative 1.6. Means kamu kira yang part sigma, kamu darab dengan YA0, you will get your epsilon. So epsilon, like I told you, can be negative, can be positive. Possible sama ada negatif atau positif. Asalkan kamu kira betul, tak kisah pun kalau kamu dapat negatif, tak kisah pun kamu dapat positif because it depends on the reaction. Some will give you negative, some will give you positive. Okay, so bila kamu dah dapat epsilon, kamu replace dalam equation dia. Kan dalam equation kata, outlet volumetric flow rate equals to inlet 5 in bracket 1 plus epsilon x. But my epsilon is negative 1.6. That's why it become 1 minus 1.6x. Basically, is epsilon tu negatif. Sebab tu kamu dapat 1 tolak 1.6x. Okay, now kamu perasan, you already express your volumetric flow rate, your outlet volumetric flow rate in this form. So kamu ganti sahaja the outlet volumetric flow rate, okay, 5 in bracket 1 minus epsilon x. Okay, so the x you replace with 0.4. Now you finally get your CA. So sebenarnya soalan ni dia hampir sama macam tadi. The only difference is nak express concentration tu you have to be careful. Sebab nak express concentration tu dah berlainan. It's really different, completely different from the other question. It's because now dia adalah gas phase flow reactor. So then you got your CA, you get your K, you can calculate your minus RA. From your minus RA, you should be able to calculate your positive RB. Don't forget, dia nak positive RB. So dah dapat minus RA. Saya ajar kamu cara daripada minus RA nak dapat rate untuk spesies lain. You already know. Okay, I teach you already. So you can get your positive RB. Okay, so finally I'm done for today. Today class is very long. I know it's 2.5 hours. I think you also are very saturated. I'm also saturated as well. So tak apa, kita sambung lagi satu soalan on Wednesday class. So Wednesday class I will continue one question and then we will continue with lecture chapter 4. Okay, so I'm done for today. I'm sure all of you are hungry, so please get your rest, please get your meal. I will see you back on Wednesday.